Welcome. I have already covered 2 lectures on the course on industrial engineering and operations research. In the first lecture, I discussed in detail what do we mean by industrial engineering and operations research. Operations research acts as a subset of industrial engineering in this context. Although operations research itself is another area, there is no doubt about that. Mathematicians also work that, but industrial engineers utilize operations research. Then in the second lecture, I talked about production planning and control, and particularly aggregate planning. I have given overview type of things, but I have not gone in too much depth in that lecture. Now today we will be discussing in more detail about the product design, and we will have 2 talks in this. One talk I am giving now, that is part 1, product design part 1, and then followed by we will do product design part 2. In the part 2 there some quantitative methods will also be discussed. Here let us start the topic. So we have to design a product. You know that industry makes the product. Sometimes you process the raw material and you may provide value to it, you may enhance value to it. You have raw material and you do processing. So here I have just shown a product life cycle, how the product is designed, how it goes into market. So this graph has been plotted between stage of development. You can see the time. In x axis there is a time, in the y axis there is a sales in terms of units, okay, maybe sales in terms of the per unit of the product sold. So we see that what happens, that when we start the product, then first it is introduction phase. First phase is introduction, that means you are just launching the product into the market. That time the sale is very slow. There is some increase, but you see rate of increase is very less, and gradually it picks up and it reaches some point. After that there is a growth phase, that each year your sale keeps on increasing in a significant way. So this is the growth phase. You see that rapidly it is growing and it is growing, but then after that maybe little bit it may slow down also, or it may be almost constant in this region, that is called maturity. So in introduction the rate of the sales in enhancement was quite slow. In the growth region it was quite high. Then at the maturity more or less it was constant, and then after that there is a decline in the sale. Gradually it is declining. We can see that this product life cycle is applicable in many products. For example, in the related to computer hardware, in early days we used to use floppy disk actually. New generation people may not have seen even the floppy disk, but in our time first you know that floppy disk was introduced, and then gradually people started purchasing. Then there was a huge demand of that floppy disk, and then finally there came that more or less it was constant, and then after that pen drive etc. came, data disk came, then you know floppy disk lost the importance and it started declining, and nowadays you do not see any floppy disk actually. Similarly, if you talk about steam engine, in the early phase James Watt developed a proper steam engine. James Watt is not the inventor, but he did modification in such a manner that it became quite useful. So since then the sale of steam engine picked up little bit, but in the beginning they had to struggle, and after that there was a rapid growth. That means everybody started using the steam engine, and then after that it became more or less constant, and now gradually the time came that there will be only few steam engines, and then what happens, that it declined. So this is what happens with every product. So that is why that it is important to understand the product life cycle. If you want to survive in the business, you should keep updating and upgrading your product. That is the message from this diagram. Now I am coming to the design. Suppose you want to make some product. So before it can be manufactured, before it can produced, it has to be designed. So we are telling you three important stages of design. In fact, other stages also there, means I am talking design per se, but you will design something, then you need specifications also based on the customer require. So you collect the specification. Specification means what type of product will be there. Okay, like if you are making a monitor, then what should be the diagonal length of that monitor, what features will be there. These type of things are called specifications. If you are purchasing some IC engine, then what is its horsepower, what is its maximum RPM, what is its size, everything it is called specification, whatever you can specify. Then you, based on the specification, you start the design. Now design has got three stages rather. One is conceptual design stage, other is embodiment design stage, third is detailed design stage. In conceptual design stage, we generate basic concepts. Okay, that means what will be the basic concept. Example is that suppose I am sitting on one bank of the river Brahmaputra and I want to go to the other side. Now I have been given this task, so I have to design some way that by which I can easily do that, a pedestrian can go easily. So there are various type of options at this stage. You can make that footbridge that human beings can go there, and in that also you have variety. You can put pile etc., that means columns type of thing, and or it can be cable type of suspension bridge, or it can be other type of method, like you can have trolley system, so that you know there is a trolley, ropeway trolley, by that also you can go, and many other options are there. So at the conceptual design stage, you only generate the concepts, that basic concept will be what, and what basic principle it will be working. So that type of thing if you work out, then that is called conceptual design stage. You just provide some concept. Another example can be that if you want to design an electric vehicle, then maybe there are some concepts, what type of battery should be used, how, whether it should be front drive or it should be four-wheel drive. Those type of concepts, you know, that little bit top level decision, and then you converge, then you can move ahead. So that is called conceptual design. In embodiment stage, you, after you have decided one type of design concept, then you provide the bodily form to that design. That is why it is called embodiment stage. That means now I may make some assembly, crude assembly, I will make that thing. I will not go in too much detail, that suppose shaft is there and on that there is some gear is there, so what will be module of gear etc. Right now I will not pay that much attention, but I will make the complete bodily shape, so that based on those things now you can make the detailed design. So third stage is the detailed design, in which you make the drawing of each and every component, and you also do design calculations, and you go in depth. You also tell that how it will be manufactured, you give guideline. So that is called detailed design stage. After that, of course, you can make a prototype, and prototype can be tested also. So this is the thing, and then you can get feedback and you can fine tune. So there are three stages of design: conceptual design, embodiment design, and detailed design. Now in the conceptual design, it takes the design problem statement and generates broad solution for it, in broadly how it will be done. Okay, I have to convert a, suppose, rotary motion to reciprocating motion, then what concept will be there, whether it will be slider crank mechanism or it will be Cayman follower, or what will be there. So solution is in the form of design concepts. Okay, and embodiment stage, concepts are converted into bodily form. We provide a body to the concept. Final check is made on function, spatial compatibility, means a space will be sufficient or not, then design aesthetics and economics. Okay, like suppose you are making a nuclear power plant, Then something you have conceptual which can be written in a book also, that this is this I will be using this type of uranium, this will be the process, this will be reactor schematic diagram. Those type of things are called conceptual design. You do not go in too much detail that what will be the physical dimension of that plant. But in embodiment stage, you will see that spatial compatibility means space, how much space it will take, how it will look, from seeing that, design aesthetics and economics also, everything you will make out that, then becomes embodiment stage. Okay. In detailed design, outcome of this stage is a set of drawings obtained by rigorous design calculations. That means once the embodiment is done, once you have decided that there will be a nuclear power plant, this will be the area it will look like, then you go in detailing that how many rooms will be there, what is that, and each room's dimension. That means in depth you will be going, that will be detailed design stage. Okay. Now, need for conceptual design methodologies. Now, conceptual design, although it is a first stage of design, but it is very important, because if you go with proper concept, then the things will be very comfortable and you will be doing this one, because this decision is not easy. You have to design. Suppose government has given a task to make a power plant. Should it be nuclear power plant? Should it be thermal power plant? Should it be hydraulic power plant? All those type of things, and among that also subcategory wise what should be there. If you take a wrong decision, the solution will not be long lasting. So, that is why need for conceptual design methodology is there, but not all design criteria can be established with mathematical precision. So, you have to do about that, because mathematical precision may not be there, but even though some concepts are subjective, you want to put some mathematical basis for that, because it will help you in reaching the logical decision. So, we will discuss some of these methods. So, for example, if I have got many schemes, what is objective way to choose that which is the correct solution, which is the proper optimum solution? How should I go about that? Should I take only emotional decision that no, I am liking this? That is not a maybe best approach. So, we have to use some concept. So, that is why we have got concept selection technique. So, we make some concept evaluation matrix. It compares generated design concept against criteria datum. That means you for concepts better than datum concept. Suppose I have some concept, compared to that it is better. So, we give that plus symbol in that attribute, and if it is worse then we give minus, and if it is same then we indicate S. Best concept will be 1 with maximum plus symbol. Instead of plus, minus and S, we can use 1, minus 1 and 0 also, many type of things. So, in fact, in about 1960, Pugh developed matrix, Pugh matrix developed by Stuart Pugh in 1960s, and Stuart Pugh, he was born in 1929 and he died in 1993. He was a British product designer. There is a quote by Pugh: "Total design is the systematic activity necessary from the identification of the market user need to the selling of the successful product to satisfy that need, and activity that encompasses product, process, people and organization." That means he is telling total design is the systematic activity necessary from the identification of the market / user need. That means first task in the product design or total design is that basically you have to understand the market need or users need. Okay, so that is first step, that what user needs, and from that point, that is the starting point, and the ending point is that to the selling of the successful product to satisfy that need. Finally, we understand the need of somebody. Somebody's need is that he needs suppose a scooter. Okay, suppose the need may be that a 3-seater scooter. Okay, nowadays scooters are two-seater, but maybe that market demands that no special type of something vehicle should be made, which should be three-seater, means maybe husband, wife and one child. Okay, that type of scooter, suppose there is a demand. So I understood that need. Then what I did, that I have, based on that, then lot of work I have to do, and I have to complete a design. Not only the design, after that I have to manufacture also, and then finally I sell that. Okay, you demanded a three-seater scooter, public demanded that, and I have sold that 5,000 quantities of this scooter, maybe in this town, okay, or in this city. So this is the type of thing that total goes, and it encompasses, of course, product, means product design has to be done, process also has to be designed, how it will be manufactured, people, public and other persons, and organization. Okay, so everything is involved in that. So Pug has given a matrix type of thing. I am explaining this with example. Suppose you have to make some product and you have two alternatives. So I have given that baseline, that means I am calling it a baseline alternative, that means against this you evaluate other alternative. Alternative 2 means another type of design is suppose 2, and then you have many things from many parameters, you have to check that which one is better. So one is the cost, that your solution should not be expensive. Other is that performance should be good, and the third one is the reliability. That means whatever you have designed, it should be reliable, it should not fail, it should not create trouble, and ease of use, then maintenance. And let us say that in a scale of 1 to 10, I have given the weightage, or maybe scale of 1 to 5, whatever you say, that you have given weight 3, 4, 2, 2, 3. That means cost is very important, but more than that, performance is important to you. Reliability and ease of use is also important. Now, based on that, suppose you say that alternative 1 got say 0 and alternative 2 means -1, that means it is worse than that. Performance wise, this is 0, this is 1, then this is 0, this is same level. Ease of use, alternative 2 is much better. If it is much better, then it is 1. And maintenance, that means it is maintenance wise, it is performance is poor, so it is -1. So what do we do that? Suppose we multiply by weight, okay, that means alternative 2 is score for alternative 2, that means 3 into -1 -3, 4 into 1 4, 2 into 0 0, 2 into 1 is 2, 3 into -1 is -3, and you add them together. So it becomes basically 0. So this indicates that both the alternatives have almost same value, and you are little bit undecided, you will decide based on the other factor. But it may be alternative may come better or alternative may come worst. I give the another example of the Puck's matrix. Okay, so here let me, it is about 3 alternatives, and this is about suppose you have got cost, and this is performance, reliability, ease of use, maintenance, total score, and alternatives are there. Let me just rearrange that matrix here nicely for you. Okay, Puck matrix, 3 alternatives. I am giving the example. Let me increase that little bit size of this thing, that here, so that you can get this one criteria, and you can actually have, yes, maintenance. Okay, maintenance, what is this one, in one table it can come, and this is what I have said. So you can see this slide, and you can actually go about that. Yes, alternative 2, yes. So now we have gone about that, and this is, let me again go to that method. Okay, Puck matrix, 3 alternatives. Okay, so I have criteria. Okay, let me also put slide name here. Okay, so this is about transaction. Okay, so it is insert, and I am putting the slide numbers. Okay, slide number. Okay, here. Okay, this is like this. and this is about, so it is about this will be yes, insert, then you have slide number, yes, and this will be slide number upright wall, okay, 11, okay. So, here let us discuss that. Suppose we have got cast and this is score is 3, this is 4 0, 2 into 1, 2 into minus 1 minus 2, 3 into 1 3 and 2 minus 2 0, 3 3 6, okay. So, you can have this is 6, okay, fine. And then this is here, let us see that if we have 3 alternatives, in alternative 1 this is 0 0, alternative 2 minus 1 1 0 minus 1, that means ease of use wise alternative 2 is much better and score for, but score means that you will multiply by weight function, okay. So, 2 into 1 is 2 and alternative 3 is little bit worse than the baseline first alternative. So, it is minus 1, but weightage is 2. So, 2 into 1 minus 2. So, like that we have done that complete thing and then we count the scores. So, here we sum that score for alternative 2 is coming minus 3 plus 4 plus 2. So, this is 0 and this is 3 2 plus 5 minus 2 3 3 6. So, that means alternative 3 is much better, okay. It got 6 score, but this score alternative 2 got only 0. So, based on that you can take a decision. But what is the drawback of concept selection method? Main drawback is the large number of combinations are possible, okay. Usually it is convenient to compare 2 alternatives at a time, otherwise you will get confused, that you know that like a match type of things, that two students are having that competition, then you can evaluate in a better way. But suppose there are 10 alternatives and if you start comparing two alternatives, you know how many comparisons you have to make. It will be 10 C2, because 10 C2 type of tournaments can be played, okay. That means 2 pair, 10 into 9 divided by 2, that means 45 comparisons. So, it is a means huge task. So, therefore, ruthlessness is required in eliminating options for quick arrival at a preferred solution. That is why you have to discard something very easily and you say that okay, this we will not consider at all, otherwise it takes time. Another type of analysis method is morphological analysis. That problem is decomposed into components or sub problems and each component represents a meaningful and identifiable part of a major problem. So, what type of thing can be done? We can make a morphological matrix. Each axis represents a major function. Each method performing the function is a coordinate along the axis and each cell represents a potential design solution. So, other dimensional thing also you can make, but we cannot make that 3-dimensional matrix. Therefore, in 2D I am explaining, say for example, morphological matrix for product design. Suppose there is something about some type of device in which there is a various options. Say suppose you have to make say coffee, let us say coffee, okay. So, power source can be battery operated, it can be manual hand pump, it can be solar powered, heating mechanism can be electric heater, it can be chemical packs, it can be external heat source, water reservoir is this, options, brewing method is this, material is this, size is this, pocket size, hand held and backpack compatible, and filter system also there may be many, paper filter, metal mesh filter and capsule pot system, many things are there. Out of that you have to choose which system. So, many combinations can be there. Maybe you can power source wise you can take option 1, but water reservoir wise you can choose option 3. So, that means like that many permutations combinations are possible and based on that you can design a product. So, that type of thing also can be done and this becomes a morphological matrix. That means function wise I have identified the module wise, like power source is one aspect, heating mechanism is another module, like that, and then I am comparing the option. So, in morphological box's chief advantage is that unusual or innovative practical solutions will not be overlooked, because I am seeing not that I am comparing two products, but I am also putting that thing that suppose there is elephant and man, I am not comparing only the elephant versus man, rather I am also comparing that if elephant's head is put in the man's that lower body on the top of that, and if man's mouth is put at elephant, then what will happen? That means we are considering various combinations. That means power source can be battery operated, but breathing method may be percolation. So, these type of things are there. So, you will have a lot of innovative options and this will be done. Then the thing is that you go to the another thing that is called statistical theory of decision. Okay. Here you apply mathematical techniques in decision making. Wherever uncertainties are present, you can use theory of probability, that you can make some robust design, you can see that what role statistics plays. And among the statistical methods, there is one utility theory also. It is developed to assist in selecting among a choice of distinct actions given the uncertainty in the outcome of each action. So, each design variable is assigned a function representing utility. That means you give some function, mathematical function, combination of values that maximize overall utility is used. Okay. So, that means it is little bit mathematical basis, and in mathematical utility theory there is one cardinal approach. Cardinal utility theory assumes that utility means satisfaction from consuming goods can be measured numerically using units called utils, okay, and that these units can be compared and added up. Another is ordinal approach, which says that ordinal utility theory posits that consumers can only rank their preference for goods and services 1, 2, 3, etc., but they cannot tell the quantitative way. So, these two type of things are used, and there is a term called marginal utility also. That marginal utility means change in total utility divided by change in total quantity. So, just see that it is mathematical thing. So, just you see carefully, change in total quantity utility divided by change in total quantity. So, suppose example is that a machine suppose has been fitted with one sensor and its total utility is 60 utils. If I add one more sensor to measure something else, then the total utility may become 80 utils. Marginal unity then becomes 20 utils, because just I added one. So, that means 60 minus 80 minus 60, that means 20. Adding one more sensor may make total utility 30. Generally marginal utility reduces. So, here marginal reduction is 10. Okay. So, marginal reduction from 20. Okay. So, marginal utility reduce to 10. Okay. So, we can say marginal utility reduced to 10. Okay. Marginal utility reduced to 10. Okay. So, we say that this is about, yes, marginal utility reduced to 10. Okay. We can say marginal utility reduced to 10. So, that is why, okay, maybe, okay, fine, I can write this in uppercase. Okay. Utility reduced to 10, a reduction from 20. Okay. So, we have in fact in economics they say law of diminishing marginal utility. That means marginal utility keeps on reducing with more quantity added. So, product designer can take a decision that how many features have to be added. Okay. So, that is what means the concept about this thing. So, I hope mostly let me just sum up and summarize the basic things. Okay. That I in the beginning I have told you should never forget this thing. Product life cycle is there, then conceptual design, embodiment stage, and detailed design stage, and we are now telling some mathematical methods or rather analytical techniques to choose the better concepts. Okay. So, in that I have told Puck's matrix. Puck matrix is there by which you can give some numbers, okay, that if it is better than this alternative then 1, if it is same then 0, otherwise -1, and you can give the weighted so that you can find out the weighted sum, you can assign the weight. Then morphological analysis we have discussed, where we have various features and each one we have made, suppose there are total 3 features and in each one there are 3 alternatives, then you have total 27 type of alternatives, because each one because that box can be this one 3, each one can be 3 3 and 3 3s are 9. Okay, I can choose that option module 1 can be in 3 ways, module 2 also can be in 3 ways, module 3 can also be in 3 ways. You can have this one and each one we can discuss analytically. Then there are some statistical theories, little bit we will discuss in part 2, but particularly utility theory is there, that we define some function, utility also is given in terms of some mathematical function or something, and I talked about marginal utility. That means marginal utility means change in total utility divided by change in total quantity. Okay, so that means marginal utility means if you increase, if you do some activity, then how much advantage you got. Okay, so marginal utility means, okay, you are taking a food in some restaurant, and now if you go to 3-star hotel with and where you have to spend maybe double the amount, but whether you will get the double satisfaction also. So that means that is called something based on that, it is quantified by marginal utility. Okay, so this part 1, and in the part 2 we will be tell some more mathematical techniques, and okay, till then goodbye.